Dear students, I am going to cover remaining theorems related to pair of lines in this session. If ax square plus 2hxy by square plus 2gx 2fy plus c represents pair of parallel lines, then h square is equal to ab, bg square is f square. So distance between pair of parallel lines is 2 root a into a plus b, or root 2 root f square minus. So as usual, so this part becomes given. Given is x square plus 2hxy 2gx plus 2fy plus c0 represents pair of parallel lines. Required to prove is first part. Second part is distance is or 2 root f square minus bc by b into a plus b. So equation is given in this format. They are not passing through origin, they intersect somewhere else. So general form of a line equation is of the format Lx plus my plus n1. Since he told parallel lines, they only differ by a constant. This is one line, this is other line, only differ by constants. So here it is L square x square m square y square n1 n2 Lx into my into Lx 2 lmxy plus x coefficient L n2, here also n1L plus y coefficient, this y into n2 mn2, here also y coefficient mn1. Now comparing like powers, x square coefficients, if you compare y square coefficients, m square is b. X coefficients, if you compare 2lm, here xy coefficients 2h. Comparing x coefficients, we get L into N2 plus N1, which is 2G. Comparing Y coefficient, here it is M into N1 plus N2, which is 2F. Comparing constants. So here it is N1, N2, here it is C. Now consider this equation. 2H is 2Lm, which implies H square. H is Lm. H square will be L square is A, M square is B. First part proof is over, and BG square AF square. I will consider these two, 2G by 2F if I take L2 plus N1 by M into N1 plus N2. So Mg is equal to Lf squaring both sides. M square is B, L square is the first part proof is over. Second one, distance between parallel lines Lx plus My plus N1 0. Another is Lx plus My plus N2 0. Is we have a formula N2 minus L1 is this, which is N1 plus N2 whole square by root of A minus B is root of A plus B whole square minus 4AB. So this is N1 plus N2 whole square minus 4C by root of A plus B. Here from this star, N1 plus N2 is 2G by L. Here it is 2F by M. If you consider it, you can write in the form of that or you can write 2F by M whole square minus 4C by, or here it is 4F square by M square minus 4C by A plus 1. 4F square, M square is A into A plus B. Sorry, M square is B. So 2 root F square minus BC by B into A plus B. Or another case, 4G square by A plus 4G square, L square is A, 4AC by A into A plus B. 2 root G square minus AC by this is how, so first part over, second part over. The last theorem which left over in pair of lines is if ax square plus 2hxy plus by square 2gx plus 2fy plus c0 represents two distinct lines, then point of intersection of pair of lines is g minus af by. Hf minus bg gh minus af by ab minus h square. So given information x square plus 2hxy plus by square plus 2gx plus 2fy plus c represent two distinct lines, so required to prove is point of intersection of pair of lines hf minus bg by gh minus af by ab minus h square. So this basic idea of simplifying, here it is given equation represents two lines which intersect, let us say at the point x naught comma y naught. Shift the origin to this point and now axis becomes new axis. So for this new axis, the same point becomes origin of capital XY with respect to small x, small y. This point coordinates are this. Shifting origin to the point of intersection of lines x naught comma y. We assumed that they intersect at x naught y naught. So then the relation between old and new system, new axis and original axis. Now ax square plus 2hxy plus by square 2gx plus 2fy plus c0. Here you have a so pair of lines equation with respect to new axis Just replace a small x small y 2g into x plus x naught 2f into y plus y naught plus c is equal to 0. Here it is a into, so rearranging the terms x square coefficient a here, so you don't find any other x square, so let me write ax square plus by square x into y 2h xy, right. Remaining terms capital X coefficient, so once you expand it to x naught x, so x coefficient will be 2a x naught. Here x coefficient will be 2h into y naught. Here you have x coefficient 2g plus y coefficient to y into x naught. That is 2h x naught. Here it is, once you expand it, so middle term will be y square plus y naught square plus 2y naught. Y coefficient will be 2by naught. Here you have y coefficient 2f. So remaining terms, here you get ax naught square. Again, here x naught y naught plus here 2by naught plus 2g x naught 2f, sorry, here 2by naught is already covered as a y coefficient. Remaining will be by naught square. By naught square 2f naught plus. So one represents pair of lines passing through origin of capital X comma capital Y axis, which implies its equation must be of the form ax square plus 2hxy plus by square 0. So, which is possible, coefficient of x must be 0, coefficient of y 0, constant also 0. So, which implies here 2a x naught hy naught plus g 0, ax naught plus hy naught plus g is 0. Similarly, y coefficient 0 means 2 times hx naught plus by naught plus f, which is, let us solving this, x naught plus hy naught is hx naught plus by naught is minus f. Just applying Cramer's method. So replacing ah with this, y naught replacing h comma b with, which is 1 by ah hb. x naught by minus bg plus hf minus af minus of minus hg ab minus. Comparing these two, x naught equating hf minus bg by y naught here is hg minus af by ab minus h square. This is what we have to prove. So which point of intersection is x naught y naught, which is hf minus bg by gh minus af by ab minus h square. Okay, that's all. All the theorems are completed. Just go through it. So subscribe the